Okay, so I'm trying to fix something here. I tried to present this the other day, and students couldn't see unless I hit swap displays. And then I just ran a test video where I did not do swap displays, and the video did not appear as it should be appearing right now, which is full screen with the slides. So if for any reason it doesn't appear that way, I do apologize. I've done everything I can to make sure that it appears properly. Okay, so let's get started on our second video of the day. We are up to our fourth lesson of the year. Things are starting to build little by little. There will be a quiz today also at the end of the session, our first quiz of the year, and we'll talk a little bit more about that later on. Actually, I'll send you an email about it. Linear equations in two variables is what we start working on today. So we're going to take the skills that we've learned and we're going to step it up a little bit. But first, I always like to go back and rehash the things we've been talking about, because it doesn't matter how fast you learn. It just matters that you learn. There are some students in this class who will get things the first time they see it. There are other students who might need to see it 5 or 6 times. As long as once you got it, you got it. That's what I'm worried about. So that's why we constantly go back and spiral and revisit our work. All right, so our agenda, the homework review and the pregame stretch, we already did that in video 1. And then we are going to do recent work recap. That'll make up video 2. And then equations in two variables will make up the third video for today. Okay, so, again, I'm going to put up the questions. We're going to do stop and start each time. And then when you're done with the questions, you stop it right now. When you're done with the questions, you start it up again and you'll check your answers. So go ahead. Okay, my son Jimmy works on a charter fishing boat in Montauk during the summers. There are 35 boats that target sea bass and porgies. Every day, each boat limits out. That is true. And that's how many fish there are. And it means they catch all they can keep. Or they keep all they can catch, I should say. Each boat catches the same number of fish. P porgies and B sea bass. So write an expression for the total number of porgies kept by the fleet. That would be 35P. Every boat catches P porgies, multiply it by 35. Sea bass, every boat catches B sea bass, multiply by 35, 35B. The fish kept by the fleet in a day. There's really 2 ways to do that. You can add up the answers to parts A and B, because that's porgies plus sea bass, or you could do one boat catches P plus B, in parentheses, then multiplies that by 35. You're grouping, in the second case, the porgies and the sea bass by a boat. When you group, you use grouping symbols. Grouping symbols are types of parentheses and brackets, and then you multiply by 35. The fish kept in a week would be 7 times either of those answers, or the best answer yet is 245 times P plus B. Okay, so that's the first one. And you'll notice that this is similar to work we did before, but we're sliding away from it now, where you have to apply what you learned before to new situations. Okay? Got a little adjustments in here too. Go ahead, try these too. Stop and start. Okay, for number 1, that's negative 4 times 7 plus 2 times 4, which is negative 28 plus 8, which is negative 20. For number 2, 4 times negative 5 squared. Now, I wanted to make sure I did this question. There's something subtle about this that's really important. I'm assuming that a lot of you use a calculator. God, please don't use your phone calculator for this, because the phone calculators don't all have the order of operations and parentheses functions built in properly. Please take the time to purchase a TI-84 Plus calculator, or TI-84 or higher calculator, because there are things coming later in the year, graphing, logs, certain exponent things, for which, or with which, the calculators make it so easy to do that work. If, on the other hand, you don't do that and you use a scientific calculator, which you can, I don't fear this. I know that there will be some questions that you will not be able to do anywhere nearly as well. And the second thing is, I fear that the scientific calculators may not be up to standard for what we're doing here. So I know that calculator costs $100. You can use it for the course and keep it for subsequent courses, or you can use it for the course and sell it used. My guess is you could get 75 or 80 bucks for it easy. And then, so you end up spending a total of 20 bucks for the use for the year. So here's a great example of why I think it's so important to use that graphing calculator. Now, if I was a student in class, I would not do the work on these third and fourth steps. I would just type in a graphing calculator 4, and now here's the key. Anytime you ever put a negative number into a calculator, particularly with an exponent, you must use parentheses. Parentheses around it, -5 squared minus 3 times 7. Now, quick little story. I taught in a town called Patchogue, a community called Patchogue, Medford, for 33 years. And one of my best buds, guy I coached with, got along amazing with, and in some of the classes that I taught, they would do inclusion, and he was a special ed teacher. So his sons went through the same school that I taught in, up in the high school. And he made sure that his sons were in my class. So, which was great. I worked with his sons. He made sure his sons were in my class. And he has this one son, Kevin, who's a real smart kid and a very, very good student, very responsible. But Kevin, oh God, I wanted to slam my head against the wall with him. There's one thing he would do wrong. He would never put negative numbers into a parenthesis on the calculator. So on his Regents exam, he wound up losing 8 points because 4 times he didn't put negatives into a calculator. And it wound up costing him 8 raw score points, which was something like 10 or 11 total points on the test. And we just shook our heads like, oh, you've been told to do this since 9th grade. It's now 11th grade. So if you want to be like Kevin, don't put parentheses around this -5. And if you want to get it right, make sure that you do put parentheses around the -5. When you do that, it comes out to 79. Okay? If you don't put parentheses around the -5, what will happen is the calculator will come back -25 here. It will not come back +25 because the calculator interprets it as 5 squared, then negated. So 5 squared is 25, negated is -25, which, by the way, is the correct interpretation, unless you put it into a parenthesis. If you put it in a parenthesis, that means square the value -5, which is why it comes up with 25. Okay. Killer question. You'll notice I changed things a little bit. I made E equal to -1 on this to give you a chance to reinforce what we spoke of before. And of course, what operations do we do first and second? Go ahead, you know the drill. Stop and start. Okay, so what operation do you do first? You do subtraction because it's inside the parentheses, but parentheses are not an operation. Okay, so it's subtraction. Next, what operation do you do second? You do the exponent. So if you wrote exponent or a little fancier exponentiation, you would get credit for that. Now, as far as the answer goes, this is very similar to work we've done on other days. The big thing to realize here is, okay, you got 2 times 9 because 4 minus -5 is 9. But then you got the -1 to the 99th, and that is -1, right? If you did not put that in, if you didn't put it in parentheses, you would have also got -1 because in this particular case, it works out the same, not because it's the right thing to do. All right, 2 times 9 is 18, 2 times -2 is -4, and just adding left to right, 28 minus 1 is 27, minus 4 is 23, okay? All right, next up. I want to emphasize more than and less than. This is probably the last time you'll see this slide. 9 more than twice a number, 9 less than twice a number. Anytime you see less than, you remember from the great Bruce Springsteen in the great state of New Jersey on the album The Ghost of Tom Joad, waiting on the day when when the first shall be last and the last shall be first. So here we go. We have 9 first. Oh, I didn't change the answers here. Should be 9 at the end. This is a typical linguist dumb mistake. And then twice a number was last, it becomes first. Again, 9, it should be a 9 at the end, minus 9, and twice a number goes first. So this should be 2n plus 9 and 2n minus 9. Point of emphasis. At one point in time, Eric Clapton had twice as many guitars. Eric Clapton's in the middle. And of course, the guitar's gently weaved, as George Harrison. Hopefully you have enough appreciation of rock and roll to understand that humor. So, at one point in time, Eric Clapton had twice as many guitars as George Harrison. Bruce Springsteen has 3 less guitars than Eric Clapton. If George Harrison had G guitars, write an algebraic expression for how many guitars the poet laureate of the state of New Jersey, Mr. Bruce Springsteen, had? Go ahead. The correct answer is 2G minus 3. So if George Harrison has G guitars and Eric Clapton had twice as many, that's 2G. Springsteen, in turn, had 3 less guitars than Eric Clapton. So Clapton had 2G, Springsteen has 2G minus 3. Okay, next point of emphasis with these algebraic expressions. And I remember talking about this the first day we covered algebraic expressions, but then I didn't talk much about it afterwards. So we're coming back to it now. So you fly from New York to Los Angeles. Where does your trip start? New York, right? Okay. You drive home from the movie theater. Where did you start? The movie theater. So notice in both of those cases, you start after the word from. In the first problem, the word from was in the beginning and you started in New York. In the second problem, the word from was after home from the movie theater. So you started at the movie theater. From always goes first in the algebraic sense. So for example, 7 is subtracted from a number. From goes first. That would be n minus 7. 19 is subtracted from twice a number. That would be 2n minus 7. So from always goes first. So anytime you see a from situation, it always goes first. If I say to you, subtract a from 15. You start from goes first. 15 goes first. 15 minus a. If I say to you, subtract from x, y, that would be x minus y, because whatever it says from always goes first. 8 is subtracted from twice the square of a number. What would that be? Remember, from goes first. Okay, so it's from twice the square of a number, so that'd be 2n squared, and then subtract 8. 2n squared minus 8. So the first one we said was n minus 7, right? Because from goes first. From a number, the n goes first. That was my dog snoring, not me. 19 is subtracted from twice a number. What should go first again, the 19 or the twice a number? The twice a number, because it's after the word from. And what about the next one? What goes first? Twice the square of a number, because it's after the word from. All right. Point of emphasis. Last point of emphasis for today with these algebraic expressions. The word sum. And we did one of these on the pregame stretch. The place, or on the homework. The placement of the word sum is critical. Compare the examples below. What's the same, what's different? Twice the sum of 9 and a number. The sum of 9 and twice a number. What's the same, what's the difference? Well, the same is that they both have a sum, they both have twice, and they both have a number. What's different is where this sum is. On the first one, it's twice the sum, and on the second one, it's the sum of 9 and twice a number. So the first one is twice the sum. So you have to get the sum of n plus 9, group it, that's why we have the parentheses there, then multiply it by 2. And the second one, it's the sum of 9 and twice a number. So that would be 9 plus twice a number. And since everything's positive, you can, by the commutative property, change the order. That's 2n plus 9. And we do prefer to have the variables in front, all things being equal. What about 5 times the sum of 9 times a number and 10? What would that look like? 5 times the sum of 9 times a number and 10. Okay, so it's 5 times the sum. So we have to do the sum, put it in a grouping symbol, multiply it by 5. Okay, again, we're working on rehashing the material. We just went a little more in depth with algebraic expressions. Now we're going to, and we did some work with variables and such, order of operations. Now we're going for some equations. Go ahead. Remember, stop and start. Okay, so on the first one, we recognize right away that this is a same size, same operation situation. Uh-oh. 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 Let's go back and make an adjustment here. When I made this slide, it was based on the other slide, and I didn't realize it was that I changed it, so I kept it 7H. That's not good. So let's just real quick change the 3H to a 2H on your paper, okay? 3H to 2H, make that change, okay? And then that gives me the 7H's, and then the rest of the problem will flow. Adding 18 to both sides, right? Because 23 minus 6 is 17. So adding 18 to both sides, 7H is 35. Dividing by 7, H is equal to 5. Yeah, one of the things is, look, when you become a teacher or whatever kind of work you do in your future, you don't want to, do things any more than you have to. So what I'll do is I will always build on the previous slides, and every once in a while, I forget to change something. I normally do it, and it's a lot, but sometimes I miss it. Part of my, that's why I'm never going to be an editor I write a lot of magazine articles, and I'll never be an editor because I just don't catch such things. Okay, on the next one, distributing the 3. Oh, look at that. See, I did it again. 3 times negative 5 should be negative 15. So this should not be 14. This is 15. The reason it says 14 is because of the previous problem. I do apologize. Always start with the smallest number of k's. Gives me negative 14 equals 3k plus 1. Subtracting the 14. 3k is negative 15, dividing by 3, and you get negative 5. So clearly I made mistakes on each of these. As long as you're doing it the right way, we're fine, okay? As long as you're doing it the right way. If you did the question as originally written, the correct answer would be negative 5.3 repeating, or negative 5.333 ... Okay? So if you didn't change the answer, which I don't think you did, the correct answer, negative 5.3 repeating. Okay, next, solving linear equations. While you work on this, I'm going to make sure that I actually did this one correctly and that I didn't make another stupid mistake. Okay. Okay, so as you're about to start, hold on a sec. As you're about to start, I didn't change this question. I'm so sorry about that. See that where it says 5 plus? Make it a 6 plus. Or actually make it a negative 6. Oh man, this is a butchery. You know what? We're going to skip this slide. Oh, you know what? No, that's not what we're going to do. We're going to put up the answer and just go through it together, step by step. There we go. Okay. So originally what I did was I changed this to a negative 6, but I forgot to change it up here, which is really, really foolish of me. 10x and negative 2x make 8x. Hopefully you can recognize that. And on the other side, we're also going to go with the new question, which is 20 minus 5x. So this is an opposite side, opposite operation situation. Just to be clear, once again, don't worry about the original equation. We're taking it from the work forward. So adding 5x to both sides gives me 13x's. Adding 6 to both sides is 26. And dividing, and I get x equals 2. By now, that should be a real straightforward, simple kind of thing. Okay? Okay, so here's our procedure for solving linear equations. A little summation step as we go along here. Are things on the same side or are they on the opposite side? That's a really important question whenever we see an equation. Then we want to work toward a standard two-stepper, things that are really simple. Then we want to isolate the variable and solve. That's what working toward a standard two-stepper sets you up to do. And last, check the proposed solution in the original equation if the question asks you to do that. So here are 10 questions for you to do. Again, we're doing stop and start. Work on these 10. I will show you the correct answers in just a moment. Fortunately, there are no issues with my changing anything in this. Next time I'll have to be a little more careful about that. Go ahead. Okay, and I'm assuming you did stop and start. If you didn't, do so now. Here are the correct answers, okay? Look them over. If you have any issues with them, maybe I made a mistake, maybe you made a mistake, you can check with a classmate, you can email me. If you need, we can set up some office hours. Just make sure you email me requesting office hours. That's always our procedure. Okay, so check those answers out. I'm going to stop the video at this point in time because there are no... Oh, do I have... Actually, I do have 2 more slides to do after this. So you do stop and start, and then we'll keep going. Okay, so now we have the potential for me to have copied something wrong. I don't think I did, but there is the potential for it because, again, I changed off of what pre-existed on another slide. Okay, so let's do just letter A. Don't do them all, just letter A. So looking at letter A, you notice this is a same side situation because, and this is the first step we had in our equation strategies. It's the 3n and the 4n are on the same side of the equal sign. 3n plus 4n is 7n, minus 5 is, oh, and look at that, it says 23. So I did copy something over that's wrong. Let's say that it says 16, okay? That's a really funny looking 16. 7n minus 5 is 16. Adding 5 to both sides, I get 7n is 21, not 28. And I divide and I get 3. So the correct answer there is 3. Okay, let's choose the next one. And I can tell you there are no mistakes on the next one. So go ahead. The first answer is 3. I'm sure you got that. Try letter B. So in letter A, we noticed that the n's were on the same side. In letter B, the w's are on opposite sides. So this is the process I should always do, is double check the first line. You can see I did copy the first line correct, so now I'll get the question correct. Always start with the smallest number of w's. Danger, danger, danger here. This 8 is a negative. There it is. Equals 5w minus 2w's, 3w's. Subtract 7 from both sides. 3w's, negative 15. Dividing, and I get negative 5 is the value of w. The good news is I did not make a mistake on the next one either. Go ahead, try letter C. Okay. So distributing the 2 to the 2x plus 3, and I get 4x plus 6 equals x plus 27. Once I've done that step of distributing, I notice that this is an opposite side, opposite operation situation, and I subtract the smallest number of x's, which is 1x. So that gives me 3x plus 6 is 27, subtracting the 6, then dividing by 3, and I get x is 7. Now we take a look at letter D, and we got 2 things going on here in letter D. The first thing that I notice is that I have a distribute, and then we're going to have a same side situation. And I want to save you some agita here. I think everybody knows how to distribute. So let us not do the distributing in letter D as it appears. Let's do it as, or solve the equation as it's written in red right here. Because, again, I forgot to change up a couple of things in this first line, and that's going to greatly affect my solution. So just do what it says in red there. Don't do the black in letter D. Okay, so again, we just worked on the red letter. I realized that the black does not change into the red. It was a mistake in copying it over. I can't believe I made that mistake like 3 or 4 times. Okay, so this is a same side, same operation situation with both the variables and the numbers. That gives me, come on. Oh, there we go. I have 12 n's, right? 8n plus 4n. And I have negative 1 and 12, which is plus 11. Subtract 11 from both sides. 12n is 36. Dividing by 12, and n is equal to 3. Okay. Last but not least, we need to work on some inequalities. So I'm going to make sure in each case that the first line, if I made a mistake, it was in not copying over the first line properly. So yes, this is the same exact thing on the first line. Go ahead, solve this inequality. Okay, so with working on these inequalities, the big difference is now we don't get only one answer. Every equation we solved up till now, the answer, it was one and one answer only. Like for instance, on the last slides, we had the answer 7 several times. So the answer was 7. If 7 was the answer, 8 was not the answer, 6.5 was not the answer, negative 5 was not the answer. just 7. Linear equations, equations with an exponent of 1 on the variable, only have one answer. This is an inequality. It's less than. So I'm not saying 3x minus 1 is 11. For that, there's only one answer. I'm saying, what are all the numbers in the world so that 3 times that number minus 1 is less than 11? And that's a very important distinction. Adding 1 to both sides, 3x is less than 12. Dividing by 3, and x or n is less than 4. First point of emphasis. If I write this answer in an answer space, it's got to say all 3 things. The variable, the inequality, and the number. All 3 things have to be there. Second, is 4 an answer to this question? No. It's not an answer because the answers are all the numbers that are less than 4. 4 is not less than 4. 4 equals 4. So 3.5 is an answer. 3.99 is an answer. Pi is an answer. Negative a million is an answer. In fact, there are so many answers that we can't fit them all on an answer space, which is why I need all 3 of these parts in the answer line, because this represents all of the answers in one expression. I use that term expression loosely, in one inequality. Okay. Very important that you have all 3 parts there and that you understand that 4 is not a solution to this problem. Okay, next up, we're going to try letter B. And yes, I copied it correctly. Thank God. Go ahead, try letter B. So my first question to you is, does this inequality have one or more than one answer? Yeah, it definitely has more than one answer. Okay, so I subtract 2 from both sides. The strategies or the processes are almost identical unless we multiply, divide by a negative. Then things change. And it might change if, depending on where the n lines up, we might want to change that a little bit too. But other than that, the process is identical. So that gives me 2n is greater than or equal to 14. I divide by 2, and I get n is greater than or equal to 7. And I want you to just realize something. First off, is 7 an answer to this equation? Yes, because it says n is greater than or equal to. That little line underneath makes all the difference in the world. It means you can equal the 7. Next, I want you to notice there's more than one answer to this. 7 is an answer, 7.5, 8, a billion, a gajillion, whatever, 93 million, whatever you want to come up with. What's not an answer is 6 or 6.9 or any negative number or 0 or 1 or 2 and so on. Anything that's less than 7 is not an answer. Only the numbers greater than or equal to 7 are answers. Now, the next thing I want you to notice in both of these is that you divided by a positive number. When you divide by a positive number, you don't go changing any signs. You started with the less than, you ended with a less than. Started with a greater than or equal to, you ended with a greater than or equal to. That's always the case when we multiply or divide an inequality, or anything for that matter, by a negative. Now we're going to try letter C. Go ahead. Okay, so first we subtract 3 from both sides. That gives me x over negative 4 is less than 6. I multiply both sides by negative 4. And now, because I'm multiplying by a negative, I have to switch the direction of the inequality. I get x greater than, and multiplying by negative 4, it cancels out the negative 4 on the left. And on the right, 6 times negative 4 is negative 24. So is negative 24 a solution to this problem? Absolutely not. Is negative 25? Absolutely not. Negative 25 is less than negative 24. Don't believe me? It's to the left on the number line. The less values are always on the left. Negative 23 is a solution because negative 23 is greater than negative 24. Also think about it this way. Would you rather owe somebody $25 or $23? You'd rather owe them you'd rather owe them 23 than 25. So negative 23 is bigger, in a sense, than negative 25. Okay, let's try the first question down here, number 1. And you can see that I did copy it correctly. Okay, so first I'm going to subtract 2 from both sides. That gives me negative 3n is going to be less than 9. And immediately, you know, it's kind of like my hackles go up a little bit. I got to say to myself, okay. So I'm multiplying here by a negative 3, which means I'm going to need to divide by a negative 3. So danger, danger, danger. I got to remember to switch that sign. Dividing by negative 3, and I get n is greater than negative 3 as my solution, because 9 divided by negative 3 is negative 3. Is negative 3 a solution? Nope. Is negative 4? Nope. Negative 4 is less than negative 3. Is negative 2? Yes. Is negative 2.5? Yes. Is negative 2.9? Yes. Is negative 4.9? Nope. Absolutely not. Okay, next one. Let's make sure I copied it over correctly. I did copy it over correctly as I checked the distribution there. Okay, solve away. Okay. So, same side, same operation. Pretty obvious here. That'll give me negative 17x's plus 38 is less than or equal to 7x plus 50. Something interesting is going to go on here. We're kind of going to get hit at a crossroads. I think it's always a great strategy, including now, to start with the smaller number of x's. So I'm going to add 17x to both sides. That gives me 38 is less than or equal to 24x plus 50. Now I'm going to subtract 50 from both sides, and I get negative 12. I shouldn't say negative 12x. I'm sorry. That should just say negative 12 is less than or equal to 24x. Then I divide by 24, and I get, this is strange now, because I get the x on the right, which I don't normally get. Negative 2 is less than or equal to x. And if you remember, we ended the last lesson by showing that there's another way to write this with, instead of putting the x on the left, we put the x on the right. Or on the right, we put it on the left. This is how it's far better to express the answer this way for a number of reasons. Involved in graphing these, involved in multiple choice questions. I can't ever remember seeing an x on the right in a multiple choice problem. So the correct answer, the best way to express it is x is greater than or equal to negative 2. Okay? Notice it points to the negative 2 here, and it points to the negative 2 here. These are equivalent statements. The statement negative 2 is smaller than or equal to x is the same exact thing as saying the x is bigger than or equal to the negative 2. Okay? If we give a specific value to x rather than use a variable, negative 2 is less than or equal to 10, or saying 10 is greater than or equal to negative 2. They both work. We just want to express it as we wrote on the bottom line. Okay, number 3, go ahead. Subtracting 5 from both sides. X over negative 4 is less than 2. Multiplying both sides by negative 4, it'll cancel out here on the left, die. On the right, you get negative 8. And don't forget to switch the direction of that inequality because you multiplied by a negative. So x is greater than negative 8. Is negative 8 a solution to this problem? No, because it's not or equal to. Back to the previous question. Is negative 2 a solution to that problem? Yes, because it is or equal to. And last but not least, had you worked on the second problem here in the middle, the big long one, if you would have chosen instead to subtract 17x, then worked out the problem, you would have had to divide by a negative at the end, and that would have arrived at the same exact solution. So either way, it gets you the same solution. Again, one of the comforting things in mathematics. Okay, this is the end of our second video for the day, and we got one more video to go.